Okay, so today's math lesson is filling this out with me step by step. So we're going to start talking about the metric system, and you're going to have a couple of days next week also working with the metric system. So the metric system, that is our topic. Currently, right now, in the US, we use the imperial system. So make sure as you fill this out after you're done, you color it in as well. Make it nice and pretty. So you guys have been working on mass, length, volume, volume in your book. And now we're going to take all of that and put it into this lesson. So for mass, to weigh something, we could use this elephant. It's a big boy. So this elephant would weigh 1 ton. If we wanted to find something smaller, the weight of something smaller, the mass of something smaller, such as sugar, we would divide by 2,000 and we would get 1 pound. So if we have 2,000 of these sugars that weigh a pound, we would have an elephant, which is equal to 1 ton. We have a pound of sugar, but we're going to weigh something as light as a key. We need a smaller measurement. So we're going to divide by 16, and that should give us 1 ounce. So we need about 16 of these keys to equal that big bag of sugar, and 2,000 of these bags of sugar to equal 1 ton. So hopefully you start noticing that the numbers here don't have any relationship with one another, right? And like the little frog is saying, where did these numbers come from? Well, I'm not sure, but whoever created them is making our life difficult. For length, runners, my track people, you run 1 mile, maybe even more, right? But something smaller, such as this baseball. I'm not gonna run the whole baseball yard, but I wanna measure the length of this baseball bat. So I divide by 1,760, and that's gonna give us 1 yard, which is approximately the size of this bat. Divide by 3, and we get 1 foot, which is almost the size of a foot. Divide by 12 and you get 1 inch, which is the size of about this paper clip. All right, and that is for length. That is what we use. We can talk about miles, yards, feet, or inches when we're measuring the distance of something. For volume, if you saw that video, I had different containers for volume. So for milk, we have 1 gallon. If you divide this gallon by 4, you get 1 quart. You divide this quart by 2, you get 1 pint of root beer. You divide by 2, you get 1 cup. You divide by 16, you get 1 tablespoon. So if you're a baker, you know what that is. Okay, so when we're finding volume containing liquids or something, we can measure by gallons, quarts, pints, cups, tablespoons. Dry volume, things that don't include liquid, such as we go picking in the fall for some kind of fruit. We could measure by bushels. We could, and then divide that by 4. You get 1 peck, right? So, a little friend here, how will I ever remember this? It's really hard to remember it, right? I, even as an adult, don't know exactly how many tablespoons are in a cup or how many pints are in a cup. I have to look that up. What I do know is how to get from 1 gallon, if I have 1 gallon, figuring out how many quarts are going to, or if I have, a gallon, how many quarts? Well, I need 4 of these quarts to make a gallon. I know how to do that math. I can do it in my head, but I don't always remember how many things, what is equivalent, what is equal. So this is called the imperial system. So the imperial system units are based on antiquated, old things like the length of the king's foot. So we get the measuring by feet and a foot by the actual king's foot, and the sizes of barley corn. So barley corn. Sorry. The quantities are completely random. So it was, I guess somebody decided they needed a measurement, and they measured the king's foot, and from there on that was like the measurement. So remember, not everyone, if I measure my foot compared to my brothers or my sisters, it's not going to be a foot, because it's only the king's foot back in the day. That king is long gone. So why is there a need for the metric system? Fill this in. Right? Why not use this, but use the metric system? Well, it's universal. It's easy. You can memorize the steps. And why not? Okay, so moving on. What makes the metric system easy? It is super easy, as I told you. Easy. So the magic number in the metric system is 10. Kind of like those rules in division and multiplication where you see zeros, and you have to multiply by 10 or divide by 10. That's exactly it. So it's building on a skill that you already have. So the magic number is 10, okay? Using length as an example. So we're going to talk about tons, pounds, and ounces, right? Remember here, 2016, they have no relation to each other. So here we have 1 kilometer in length. In the metric system, we use meters, right? I have a meter stick, the one that Adrian is always swinging around, right? And I tell him, how come you always manage to find the things that you're not supposed to touch? Yes, the meter stick, right? So 1 kilometer divided by, you guessed it, 10, is going to be 1 hectometer divided by, 10 is going to be 1 decameter divided by 10 is going to be 1 meter. Uh-oh, I gotta put this backwards. Is going to be 1 meter, right? And that's my meter stick, the one that I have in class. The next one divided by 10. So if I have that meter stick and I divide by 10, that's going to give me 1 decimeter. And then if I divide this decimeter by 10, that's going to give me, flip it all the way, 1 centimeter, which is about the size of your fingernail. Divided by 10, that's going to be 1 millimeter. So even smaller than your nail, right? 1 milliliter. If you want, you could always go and find this video and watch NASA failing a measure. Okay? The magic number is 10. All right, flip to your next page. All right, so what are the SI units? SI units. So SI stands for Système International, which is French for the international system. And as I said before in the other page, why is it important? Why is the metric system easy? Because it's international. I think I spelled it right. I'm not sure. But it's international, which means that you can use it almost everywhere in the world. Except, you know where? Take a guess. Take a guess. The U.S. We also have Burma, another country, and Liberia that do not use it. They have their own way of measuring. But almost everyone else in all of these countries, they use the metric system. So why are we the ones that don't? We're measuring in feet. We're measuring in pounds. We're measuring in, gosh, bushels. And in, what was the other weird one? And in pecks, right? Other countries are measuring in the metric system, and we don't. So the SI units are internationally standardized so that there is a common language between nations and different branches of science and technology. So take the corona crisis right now. A doctor over here in Russia finds out that to cure corona, they need 3 milliliters of a specific shot, right? And then over here, our wise guys in the United States are trying to figure out, well, what's 3 milliliters in a quart or a pint or a teaspoon or a tablespoon, right? We should be able to figure that out. Or we solve the cure for corona and you need 1 pound of sugar in tea to fix the coronavirus, to get better. Imagine. Other countries around the world are going to be like, what the heck is the United States talking about? A pound? What is that? Britain over here, Big Bad Britain, uses their old system for money was called a pound. So we need money, a pound of pounds of money, right? It's going to be very confusing. So that's why the metric system is used commonly, so that this helps with science and technology. Moving on. What are some metric base units? So we need to know these base units because no matter what the base is, it's always going to stay the same. And I'll explain what that means. So when we measure in length, can't spell. That's why I don't teach English. So length, we measure in meters. It is always going to be meters. Now, it might be millimeters, it might be centimeters, it might be hectometers, it might be decameters, it might be decimeters, something, right? But it's always going to be meters. That is why it's called a base. So we're going to put an M in parentheses. That's the abbreviation. For mass, for weighing stuff, we have grams. A gram. Grams, plural. Meters, plural. And that is a G. For volume, when it's fluid, we use liters. And that's capital L. Notice how I did a capital L over there. And then for time, yes, time is included. Hold on, I gotta go back. Volume and time. Okay, so for time we have seconds. Okay, so that is the base. Meters, grams, and liters, and seconds. But pretend this one doesn't exist right now. These are the main 3 ones that you'll see. Okay, what are the prefixes? So, hopefully Miss P taught you what a prefix and a suffix is in grammar. And if not, well, pre means before. Fix is the starting of like a word. So, for example, if I have, gosh, I gotta think of English now. Decompose, deconstruct, dehumanize, I'll come back. But all of those are prefixes. We also have them in math. Well, we're not going to use those. We're going to use some other one, right? We're going to have kilo, which is K, for the abbreviation. You put the abbreviations together, km. I'm sure you've seen this before. So we've got kilo, we've got hecto, which is an H. We've got deca, which is a D. I believe it's also DEC, but don't quote me on that. I gotta come to that. Then we have our base unit. So base units here would be meter, liter, and gram. Okay, these are our base. This is kind of like a starting point. And then from here it gets bigger, and then from here it gets smaller. So a gram, let's suppose this is a gram, right? And then this would be getting smaller and smaller and smaller until we reach to like my fingernail, and then even smaller than my fingernail. Okay, so that's just kind of an example. Not accurate, but kind of an example. So the base, then we have, oh, you know what? Yes, you were right. No, it is decimeter, which is just D. We've got centi, so I'm sure you've heard centimeters. It's on a ruler. Look at a ruler every now and then. Make sure you know how to measure. And then we've got milli, 2 L's, just an M. Okay, so these are our bases. You get larger going this way. So if I have a meter stick, if I have a kilometer, that means that it's way bigger, right? And then moving down this way, these are the small guys, the small fries. Last, number 6, what is a mnemonic device for remembering these prefixes? Mnemonic, that is a cool word. Make sure you know how to spell it. Mnemonic. Okay, mnemonic device. And if you haven't covered mnemonic devices, it's kind of like your dear Aunt Sally. Remember that beautiful woman? PEMDAS, please excuse my dear Aunt Sally. A mnemonic device is like that. It helps you memorize a certain kind of thing. Like my very energetic mother just served us 9 pizzas, right? Mercury, Earth. Mercury, Venus, Earth, Mars, blah, blah, blah. Okay? So, mnemonic device, kind of like a way to remember what something stands for. So here we're going to meet not our Aunt Sally anymore, but this is our dear friend King Henry. So, King Henry, what a handsome chap. Well, guess what happened to him? He died by drinking, you won't believe it, what do you think? Chocolate milk. Did he snort it out of his mouth? Who knows? Was it poisoned? Who knows? But we just know that King Henry died by drinking chocolate milk. And guess what? King, kilo, hecto, Henry died, deca, gram, base unit, by drinking deci, chocolate, centi, milli, milk, right? Mind blown. All right, next page. I'll try to finish this. Okay, so in this, it's all about the decimals. Your dear friend, the decimal point. It's not going away. You thought you were free? Nope, it's not going away. So remember that every whole number has an invisible decimal point at the end. For example, 849 is actually 849.0, right? And this kind of rule, the invisible zero or the invisible concept, also applies to fractions. Remember, 849 is also a fraction if we were to put a 1 underneath it. Obviously, this looks ridiculous, and we've talked about that before, so we don't write it like that. But also, it is the same concept for decimals. We don't have to write that 0.0 because it looks silly. No need. All right, so how do you convert? Convert is change. convert between metric units. So you guys spent all of last week, I believe, trying to figure out how many pounds were in a ton, right? If I was baking and I needed quarts, how many gallons does that equal? Crazy kind of stuff. And if you watch my video, I told you that's not my favorite. I like this King Henry stuff. And yes, I am upset that we don't use it in the United States because it's so easy and it's universal. You can connect with so many countries and people with this. Do I always use it? No. My family tells me, how many meters are you? What do you mean? I know I'm 5 feet, right? So I don't really know how, I know how to use it, but I don't know exactly measurements. My mind is not programmed that way. I was programmed in inches and feet. Crazy. So King Henry died by drinking chocolate milk. Please go ahead and fill this in. This part, bottom part right here, you already know, but I'll fill this in with you. This is the base. Remember, and the base we have 3 different things. We've got length, which is meters. We've got mass, which is grams, and volumes we use liters. And make sure that this is a capital L. Okay? You know what? I'm just gonna do it. And okay, so if we were to fill this in, we know that kilo, we're talking about length. We have meters, kilometers or kilometers, whatever, hectometers. We're just gonna stick with the 1D, okay, and make it capital D. Don't add this A. I've never seen it like that. We're just gonna stick with these. All right, decameter, meter. You can't forget this one. This is still a spot. All right, decimeter, centimeter, and millimeter. All right, kilogram, hectogram, decagram, gram, decigram or decigram, centigram, and milligram. Kiloliter, hectoliter, decaliter, liter, deciliter, centiliter, and milliliter. This one's most common, or liters, right? The other ones aren't as common if you bake. All right. So when we're moving from any of these, let's say I have 10 centimeters. All right. I'm starting over here. 10 centimeters. And I want to figure out how many how many kilometers are in 10 centimeters. All right. When I move from here to this way, I have to divide by 10. So that means I gotta hop to the left, moving the decimal point to the left. Okay, so what that means, if I have 10 centimeters, remember here I have an invisible decimal and a 0. So that means I'm gonna hop from centimeter 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Drop my decimal. I divided by 10, right? 5 times. So I divided by, okay, I divided by 1,000, and that gave me 0.00010. What is that? Something in the thousands. I gotta think. I gotta use my brain. Millionths? I want to say millionths, right? But that means I'm way off to the side. This is such a small quantity. If I were going from hectometers, let's say I had 364 hectometers and I wanted to go to kilometers, I only have to do 1, divide by 10, And remember, butt cheeks, 1, 1. So that would be 36.4 km. So 36.4 km is equal to 364 hm. The only difference is that there is a decimal point. So it's the opposite if you're moving this way. If I were to have kiloliters, let's say let's say kilograms. I have 67 kilograms. And I want to know what kilograms is in grams. So that means I got to multiply by 10 because I'm moving to the right. Kilograms. 1 butt cheek, 2 butt cheeks, 3 butt cheeks. And you start from here. So 1 butt cheek, 2 butt cheeks, 3 butt cheeks. Grams. All right. Don't worry if you don't get this just yet. There will be other videos and I'll link some other stuff. So how to use this slider. So you put your finger on the unit that you're starting from. If I were to start from kilograms, I would put my finger here. Hop left or right to the unit that you want to convert it to. So for example, if I have 67 kilograms and I'm asking you what that is in centigrams, right? You're going to start here and you're going to hop that way. So you know you're moving to the right and there's a fancy arrow pointing that way. Okay? So you are, believe that you are starting from hop left or right to the unit that you want to convert to. Count the number of hops. Remember, don't skip that step. Count it 1, 2, 3, 4, 5, whatever. Make sure that you count it that way you don't like overlook it because you might think 1, 2, 3, 4 and then you forget that it's 1, 2, 3, 4. You might miss one. Okay, so count the number of hops. Move the decimal point. In the original number of spaces to left or right. So again, so if I'm going from 1, 2, 3, 4, 5, right? There's no decimal point here, but I know there's one at the bottom. So I gotta move, there's 5 spaces, and that means it's gonna get 5 zeros. It's a lot, right? And it makes sense because if I'm moving from this side, this quantity is gonna get bigger. If I'm moving from this side to that side, the quantity is going to get smaller. I went from up here having 364 to 36.4. It gets smaller that way. It gets bigger going this way. Okay. For example, if you want to convert 27.4 grams into milligrams, so grams to milligrams over here. Well, it's going to get bigger, right? It's moving to the right. It's going to get bigger because we're multiplying by 10. So, where did it go from grams? 1, 2, 3. So, 1, 2, 3. I start with my finger on grams. I hop 3 times to the right to get to milligrams on the King Henry slider. So I move the decimal point in 27.4 3 spaces, 3 times, whichever one, 3 spaces to the right, boom, 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 and you get 27,400, and your period is right there, right? Okay, this is the same as multiplying 27.4 by 10 times 10 times 10 times 10, or by 1,000, right? 1, 2, 3, 3 zeros, 1,000. So 27.4 grams is the same as 27,400 1,400 milligrams.